In Vedic maths there are plenty of different ways in which numbers can be divided, and this is applied, this is valid not only for numbers but also for algebraic expressions. And I'm going to start this session with Nikhilam Division, and this begins with the division of numbers by 9. I'm going to start in a very simple way. We're going to look at 9 divided into 10, and you'll find that I write the answers underneath for convenience. And we know that 9 into 10 goes 1, remainder 1. And if we look at 9 divided into 13, we have 1, remainder 4. And 9 into 23 goes twice, remainder 5. And 9, another example, 9 into 53, it goes 5 times, remainder 8. And you may have noticed that in every case the remainder is the sum of the two digits. So here we have a remainder 4, it's 1 plus 3. Here we have a remainder 5, it's 2 add 3, and 5 add 3 is 8. That gives the remainder here. We can utilise this for longer divisions, like 9 divided into 1, 1, 2, 3. And we can sum the digits. So we bring down this 1 and add it to the next one, making 2. And we add this 2 to the next digit, making 4. And then add the 4 to the 3, giving the remainder 7. 124 remainder 7. And an even larger example, 9 into 10231. And we can portion off the remainder section and then just bring the 1 down, add it to 0, giving 1. 1 add 2 makes 3, 3 add 3 is 6, and 6 add 1 is 7. So it's 1136, remainder 7. Of course, if the numbers here get too large, then we may need to do a bit of further division. So, for example, 9 into 58. Here we can bring down the 5, add it to the 8, and it gives a remainder of 13. Well, that's more than the divisor 9. So what we have to do here is to redivide this remainder, and we can use the same process. 9 into 13 goes 1, remainder 4, and this 1 would then have to carry over to the 5, making 6, remainder 4. So that's the first step. Now we can utilise this summing of digits for larger divisions. So, for example, 97 divided into 104. And this is where we actually begin to use the Nikhilam Sutra, which means all from 9 and the last from 10. And that gives us the complement of 97. So we take the 9 from 9, it's 0, and the last from 10 is 3. And that gives us the complement of 97 from 100. We apportion off, the base is 100 with 2 zeros, and we apportion off that number of digits to the remainder portion. We bring the 1 down, and then multiply this 1 by the 03 to give 03, and then sum up to give the remainder 07. And this can extend to longer divisions, so 97 divided into 1103. Again, we apportion off a remainder section with 2 digits, and the complement is 3, it's the same. We bring the 1 down. 1 times 03 is 03. We then add up the second column. 1 adds 0 is 1. And again, multiply this 1 by the 03, giving 03, and merely add up for the remainder. 3 add 3 is 6, and this one makes 3. So the answer is 11, remainder 36. Now let's extend it to another divisor, 93 into 2014. The complement this time is 07. we bring the 2 down. 2 times 0.7 is 14, we write that in the next 2 columns. Add up the second column, giving 1. 1 times 0.7 is 0.7. And then add up for the remainder. 4 add 7 is 11. And 1 add 4 add 1 makes 6. So the answer is 21, remainder 61. And let's move on to a larger one. This looks more impressive. 989 divided into 21,452. Here the base of the divisor is 1,000. We're relating 989 to 1,000. And the complement is 0. 9 from 9 is 0. 8 from 9 is 1. 9 from 10 is 1. So the complement is 11. This time we apportion off 3 digits for the remainder section because there are 3 zeros in the base. Bring the 2 down and multiply this 2 by the complement, giving 0, 2, 2. And write those in the next 3 columns. Add up the second column, giving 1. And multiply. 1 times 0, 1, 1 is 0, 1, 1. And then merely add up for the remainder. It's 3, 8, 6. So it's 21, remainder 683. And there are cases when we do have to redivide the remainder. Let's have a look at this. 91 into 481. Here the base is 1,000, so 2 noughts, and so we give 2 digits on the right hand side. The complement is 0.9. Now when we bring the 4 down and multiply it by 0.9, we get 36. And adding up for the remainder gives 117. But this is bigger than the divisor 91, so here we have to redivide the remainder, and we can use the same process. 1 remainder, we add the 9 there, so it's a remainder of 26, and this 1 has to carry on to the carry over to the 4, making 5, so it's 5 remainder 26. Well, that's just an introduction to Nikhilam division. I'll show further steps in the next video. The question naturally arises is, can this be applied to decimal division? Not easily is the answer, but we'll have a look at decimal division another time.